So as you've noticed right now, we can make an almost infinite amount of different compounds just using even carbon-carbon single bonds. And so we need a way to talk about these to one another. So we need a system of nomenclature or a way to name these, right? So this will be about naming compounds. And we're going to use the convention most often used, and that's the one created by IUPAC. IUPAC stands for the International Union of Pure and Applied Chemistry. You don't have to know that. Basically, they just made up a whole bunch of rules to name all of these compounds. Now, if you do some kind of literature search, you'll often see that compounds have what's known as common names. So back in the day when organic chemistry first came out, people were just naming compounds whatever they wanted, right? Oh, I'm going to name this compound after myself because I discovered it. I like this name, right? It was just all totally random. And some of that still persists, but there is a systematic way to name them. And so we're going to learn the systematic way to name them. And for now, we're just going to do alkanes, which are the carbon-carbon single bonds, and cycloalkanes. Cycloalkanes are just alkanes, but they're cyclic. And what that means is basically it's kind of like a circle, but they end on each other, right? So maybe a triangle, you see how that's kind of a system, or a square with 4 carbons, or a pentagon. These are all cycloalkanes, or maybe a hexagon, right? 6 carbons, but they're fused together in a ring type of setup. So let's learn this naming system. First off, we start off with alkanes. And for here, we're going to add the suffix of ane, right? So the ane, anytime you see ane, that means that you have carbon-carbon single bonds. And then we can add a prefix to this, which tells us how many carbons we have. And so this is something that you need to memorize. It's not too hard. We add the prefix meth, means 1. Eth means 2. Prop means 3. But means 4. Pent means 5. Hex means 6. Hept means 7. Oct means 8. Non means 9. And dec means 10, right? And there is beyond 10, there's nomenclature for that as well, but we're just going to stick with 10 for now. And so what you do is you combine the prefixes with the suffixes and you make the name. So for example, propane, right? Prop means 3. The ane means all carbon-carbon single bonds. So propane would be this compound right there. 3 carbons, all single bonds. For another example is hexane. Hex means 6. Ane means all carbon-carbon single bonds. And so you need to draw a compound that has 6 carbon-carbon single bonds all in a nice line, right? There's no branching or anything like that. We'll get to that later on, right? So 1, 2, 3, 4, 5, 6, right? That's hexane right there. We can add another prefix for cycloalkanes. And this prefix, ready for this? It's cyclo, right? Cyclo. So for example, if we want to draw cyclo propane, right? Cyclo means that it's going to be cyclic. Prop means 3. And then ane means all carbon-carbon single bonds. So just be essentially a triangle, right? 3 carbons in a cyclic fashion. Another common one we'll see and study in depth a bit later on is cyclohexane. Again, cyclo means that it's cyclic. Hex means 6. Ane means all carbon-carbon single bonds. And so we're going to learn a whole bunch of other rules for naming for quizzes and tests. I will give you the name and I will ask you to draw the structure or indicate something about the structure. I will not go from structure to name. So I won't give you the structure and ask for the name. And the reason that I won't do this is that there are a lot of little rules. There's all kinds of scenarios. Well, if this, then that, if this, then that type of thing. And so I'm not really concerned that you really know IUPAC naming that well. I'm concerned that if you are given the name, can you identify the structure? This top one's definitely the easier one of the two, but it's also kind of more useful, I would say. There's just too many details that we're really not going to spend a lot of time on. We've already got so much material to cover.